under load within the system. So we've had videos in the past of how to check a capacitor not under load by removing the capacitor from the circuit, discharging the capacitor, and then checking the microfarad readings across the terminals of the capacitor itself. But today we're going to talk about how to get an accurate reading of what's going on with that capacitor while it's actively in line in that system, while it's helping the compressor start, while it's helping the motor continue to run. We want to see what's going on within that capacitor. As always, we're in a lab setting here, so we're not going to be able to cover every single scenario and setting. If we did, we'd be on this video for the next 15 days. But that being the case, we're going to show you just this one particular example of how to check a capacitor under load. Let's get started. Okay, so we're here at the outdoor unit. We've verified that the system is on and running, and that we are at steady state. So the system has been running for 10 to 15 minutes, and we know that our pressures are about where they're going to be while the system is actively running. So from here, we want to check this capacitor, find out how it's actually operating while it's in use. So to do that, we're going to take our meter and set it to amperage. Once our meter comes on, first we're going to check the amperage of the fan terminal, which you can tell it's hooked up and says right on top of the capacitor that that is the fan terminal. So we'll go ahead and hook up our meter, and it says that our amperage on the fan terminal right now is 1.0. We're going to do the same thing across the hermetic terminal or the compressor terminal. We're going to go ahead and hook up our meter to that. And as you can see, it says that our reading is 4.4 amps. So 1.0 and 4.4 amps. You're going to want to write both of those numbers down. From there, we're going to take our meter and switch it over to voltage. And we're going to check the voltage across both of those terminals to common. So we're going to start first with our fan terminal, which is reading 271.0 amps. Again, write that number down. And lastly, we need the number from the compressor. Same thing, we're going to go across the common terminal to the hermetic terminal. And that is going to give us 297.6 volts. 297.6 volts. So from there, we are going to take those numbers and plug them into the formula, which that formula is 2,650 times the amperage divided by the voltage. So for the fan, we have 2,650 times 1.0, which is obviously going to give us 2,650, divided by that voltage, which was 271 volts. So that capacitor is running at 9.7 microfarads while it's in operation. With this particular capacitor, it is a 40 plus 10. So we are at 9.7 while that fan is operating. So on the fan side, that 10 side, we know that we're good. Same thing for the hermetic side of things, or the compressor side of things. We're going to take 2,650, multiply it by the 4.4 amps that we had, which gives us 11,660. And we're going to divide that by our voltage, which was 297.6, which gives us 39.2 microfarads. 39.2. Again, this capacitor is a 40 microfarad for the compressor side. So while it's actively running, it's running at 39.2 microfarads. That's the process to check the capacitor itself while it's under load. Again, make sure that you're careful, that you don't cross those leads in any way. You can get a bit of a shock. So this is the most accurate way to determine how that capacitor is responding within the system. If there's a different way that you check it out in the field or things that you've run into,